Good afternoon, ladies and gentlemen. Please don't all of you leave. We have another amazing session planned for you. So the afternoon is just getting started with all things machine learning, AI, ML. So as you see, we are setting up stage for a panel. Please join me in welcoming Jagdeep Singh Bachher, who's currently serving as the Chief Investment Officer of the Regents University of California, the Office of President, where he's responsible for managing a $118 billion fund, which decides and determines where the UC endowments, pensions, retirement savings, etc. will be invested. And he is also a part of the TiE family. He's one of our board members of the Silicon Valley chapter. And he's going to lead a session about thought leaders in AI. This is a session not to be missed. I will let him introduce the other panelists when he gets on board. So please join me in giving a huge round of applause for Jagdeep Singh Bachher.
It is super difficult to see everyone in the audience here, which means we don't need to get nervous. It's kind of like a little skit. Thank you all for paying attention on a Friday afternoon. I'm Jagdeep Singh Bachher. I work at the University of California, and I'm super excited because I have 3 more University of California friends. Let me start with Ken Goldberg. So Ken and I have only known each other for a couple of years, but some of the things I'll describe to you about Ken's background will make sense very quickly. I'm sure you've all guessed by now that he's a professor of industrial engineering and operations research at UC Berkeley. He's also a chief scientist at Ambi Robotics. That's a coincidence we have. I'm an investor in Ambi Robotics. But he's also well known for being an artist and a writer. And so quite a few things for a professor there. I think you've got 2 degrees in economics and electrical engineering from the University of Pennsylvania, and then your graduate work is at Carnegie Mellon University. And you also have a cross appointment at the UCSF Medical School where you work on medical robots. Mm-hmm. Now, I have to admit that you were probably thinking we were going to have Pradeep Khosla, who's the chancellor at UC San Diego, here today. I'm sure you all appreciate there's a lot going on in universities and colleges at the moment in America. And when the chancellor and I spoke last night, we both felt it would be good for the chancellor to be physically present on campus. And so in that context, we hope to keep up to what the chancellor would have provided Pradeep in today's panel. But I'm confident that my 2 other panelists, Tara and Max, are going to do a fantastic job as well. Max, to my right, is the founder of Jacobi Robotics. He's worked in Norway, and he studied at the Imperial College in London, where he got his Master's of Engineering. You can correct me if I've got anything wrong.
Yeah, that's
this
right.
was all AI generated in terms of bio. And also, you've studied at the UC Berkeley.
I have, yeah.
He recently stepped out of academia. He created Jacobi Robotics with Ken. They just raised their seed funding, and they just came out of stealth. So very exciting times in the field of robotics and starting a company. And then, last but not least, Tara. I want to make sure I pronounce your last name correctly. Sadjadpour?
Yes.
Excellent. Tara is Ken's student. I met Tara for the first time maybe a month ago when I came over to your Center for Artificial Intelligence in Berkeley. I had a chance to see some of the robots working around in the lab. But you're an electrical engineer as well. And I'm sure you'll be very convinced that one of Ken's overachieving and articulate students is on the panel today. So the way and by the way, I'm a mechanical engineer. I just kind of feel a little out of place of not adding engineering to all of your backgrounds. But the way I'd like you to think of the panel today is professor, student, entrepreneur, investor. And that's a combo that everyone probably is thinking works someday in the world of artificial intelligence of bringing all these formulas together. So I'm excited. Let's have some fun. By the way, I have to tell you, Ken and I, we both like shoes as well. He beat me to the cooler shoes today. He does like pocket squares. I like that about him. But what you didn't know is that he and I were both born in Nigeria in the same city. Who on earth would have thought that for a combination of two guys getting together in Berkeley? So,
yeah, we are brothers at some level.
We're brothers. We both look cool.
Totally.
We'd have to check on the DNA and the moms. But we'll figure that out later, my friend. And before I dive into this today, I also want to take a moment and acknowledge my own team at UC Investments. I know I've had my team dedicated in this meeting for the last couple of days, and we've had 101 students from the University of California participate over the last 3 days in training that has been offered by TiE. 25 of my team members in addition to that, and I'm just very grateful for the hospitality and the way TiE has embraced our students to help create the next generation of hopefully AI entrepreneurs and professors and researchers. So thank you, and thank you, Anita, for letting us have this panel today. So I want to start with, AI. We just heard the last panel. AI it's sort of everything. It's water, it's air, it's also confusing from my perspective. How did you all get involved in artificial intelligence? Because all of a sudden, you're the coolest student, you've got the coolest startup, you're probably going to get more research funding than you can imagine because you're studying AI. But that didn't happen overnight. What was the journey that brought you to this point of being in this hot arena of technology? Should I start with you? Let's go with Tara, ladies first.
Yeah.
Sure. So my start in engineering began when I was about 12, 13 years old. My dad is a professor at UC Santa Cruz in electrical engineering, so he had a huge influence on me. And when I was younger, I had taught myself C programming using one of the books he had from his PhD in our home library. And then eventually that led me to AI through undergrad and all of that.
But was AI a thing when you were learning, or you just found yourself in the middle of AI in the last 2 years?
So I originally was doing research in information theory, but then a lot of information theorists were interested in machine learning, and I wrote a paper on info theory and machine learning, and that led me to AI.
Fantastic. Thank you. Max?
Yeah, so I had my sort of initial interest in AI after Google DeepMind's breakthrough, AlphaGo, back in 2016, when this computer managed to beat the world's best human player at this game Go. That gave me that initial interest to do more research, to figure out what is this AI, what is it, how does it work, what's the potential, and then over the next few years, just looked into that on my own initiative, really. Took some courses. My background is in mechanical engineering, so took some computing courses there. And then what got me really excited was AI and robotics, because it was the thought that, okay, the potential of AI, if we can apply that to robotics, then that can go beyond the digital realm into the physical world, and we can manipulate our environment. And that's what really excited me. And so sort of try to get to the state of the art of AI and robotics, and that UC Berkeley was on the top of my list there. And so when I got the opportunity to work with Ken at Bayer, I jumped on it and have been at it ever since.
Awesome. 2 mechanical engineers, 2 electrical engineers. Ken?
Okay, thanks. And I want to say thank you so much for inviting us and for bringing my students here, who I'm so proud of. My history was that when I was a kid, I was into rockets and robots.
I couldn't tell.
I was nerdy. I mean, my father was an engineer too. So we would build things in the garage, and one thing he taught me was how to do binary numbers and little circuits, and I would switch and build counters and things like that. And then he had, at some point, wanted to build a hoist for his company, a small company, and it was a robotic hoist. So we spent countless hours in the basement working on this thing, And it was way ahead of its time. I mean, it never really worked, but it got me inspired about robots. And then years later, I was in an undergrad spending a year abroad in Scotland, and there was a fair to choose your major, to choose courses. And there was a table there that had the sign AI. And when I saw that, it was like love at first sight. I walked right over, and I was like, sign me up. And so that was the beginning. I took a whole year of courses on AI and robotics when I was an undergrad. And then I got into a lab, and I've been doing it ever since.
Very cool. So very quickly, just one piece of advice you would give for the younger crowd in here today as to how to get a breakthrough into the world of AI. Tara? And super quick, then I'll move on to the next question.
I think focus on fundamentals, because right now a lot of AI research does look similar to each other. So if you have a big picture view of everything, you can innovate more than others around you and stand out.
Okay, Max?
I think being proactive and looking for opportunities, not waiting for someone to give you an opportunity, but go look for them and try to enter the field you're interested in.
Excellent. Professor?
Okay, the thing that has really changed the landscape is the robotics competitions, like FIRST and VEX. And they are amazing. All students getting involved in these, and there are students doing high school robotics clubs, and by the time they get to college, they have a lot of experience. And so it's been a huge benefit for the field. And I recommend any student to try that out as early as possible.
Yeah, so get involved super early, and that's a common theme to all of your life. So hype versus reality. I'm an investor. I get a lot of interesting pitches from AI companies. 99% I don't understand. How do I separate the hype from what is real and has breakthrough potential? Why don't I start with Ken, because you've had a longer time to see these types of companies.
Well, I know exactly what you're saying, Jagdeep. There's a lot of things that they sound too good to be true. And I think they often are too good to be true. And it's important to be skeptical, not cynical, because there's amazing advances happening, and there's no doubt about it. We're living in a very exciting time. But, for example, the people sometimes talk about exponential growth. We're in this exponential time. And I think that is an example of hype, because if you know exponentials from math class, right, exponential is very hard to live on an exponential curve. Now, Moore's law is the exception, but I don't know many other exceptions. And some things, like air travel, have gotten worse over the past 20 years. So it's not always, all technologies are not exponential. What I think there is punctuated equilibrium, where there's a breakthrough, then there's a plateau, then another breakthrough and a plateau. So I think we've just had a breakthrough, which is Gen AI, and hopefully we'll talk more about that. But there's going to be a plateauing period, and I think it's important to sort of set the expectations, because I worry a little bit about a bubble, where everyone feels that robots are around the corner, and we've seen this before, and then there's a backlash, and everybody is very negative. So I want to dampen, I was going to say curb your enthusiasm a little bit, so that we don't overheat this sector. But I am very, very positive about it. And the reality is that robots are doing amazing new things. And we can talk more about where that's happening and where those applications are later.
And we can come back to robotics specifically. But Tara, when you are hanging out with friends and other classmates, how do you all distinguish between what sounds, I'm sorry, I'm going to rephrase my question. Let's say you got a hot startup that wanted to hire you. How are you going to decide if this startup is really a hype or a reality? Because that decision is going to impact where you spend the next 4 or 5 years of your life. And you hope it's the right one.
I think what you were saying earlier about things that sound too good to be true is definitely something you should stay away from. You should seek out opportunities that are grounded in reality, not grounded in hope, right? Because a lot of people want to see fully autonomous agents, but it's very unlikely that that will happen. I think if a startup talked about building robots that could collaborate really well with humans and they could each augment each other mutually, that would be really attractive to me. That's something I would buy.
Okay. Max, is your startup a hype or reality? Hey, I'm an investor. I can ask these questions, and you kind of have to answer them, right?
Well, you know Ken very well, and in the lab we have a very strong focus on rigor and not over-promising, under-promising and over-delivering. And so, when we decided to start this company, it was very important to us that we don't over-promise, that we deliver on what we set out to do, that we don't overhype it, and I think the key measurement for us is sort of software in deployment, in the field, in production, right? If you can get to that stage, if you can have robots in production, then I think that's the real proof point.
Okay. Under promise and over deliver. I still don't understand what the KPIs, or how do you measure over delivering, or over under. You
okay.
got it.
Well, there's two KPIs I would tell you. One is the people.
Okay.
So I would really look at the people carefully.
Got it.
Because really look at their backgrounds. If they are really coming from top-notch places and they have top-notch credentials, that is number one important. And it shouldn't just be one person. You need a couple of people at the company who really have that kind of, because they're also going to attract others around them, and they have high standards, and then they're going to set that, and then other people, because engineers have a lot of choices, so they want to go where other great engineers are. So that you need a critical mass of great engineers. The other thing is, the KPI is do something that's actually working in the field, where people are using it day after day. That is really a big test, and it's so hard to go from the lab to that point. But once you have real working systems, check how often they break, how the customers feel about them. But if they're happy, then that's a great sign.
Yeah, I think speaking to customers is the ground truth.
In terms of what the applications might be?
Yeah, of course. In terms of the maturity of the technology.
Okay. So I think Ken, you've touched on a point which is important for us as investors: is who are the people, where are they coming from, and let's take a moment, because we're in California. There are going to be some hot spots for artificial intelligence talent in the world, and I think Berkeley is absolutely going to be one of those hotspots. Talk a little bit about what that hotspot looks like today, and if you're a young high school student whose parents are in the audience, because the students are in school today, why should they and how should they think about the talent and Berkeley?
Okay. Well, I'm a little bit biased, so keep that in mind. But we have something that we started at Berkeley about 6 years ago now called BEAR, Berkeley AI Research Lab. And BEAR now has about 70 faculty and about 500 students, PhD graduate students and undergrads, but they're working together in all aspects of artificial intelligence. And the standards are high. So we have, as these two can attest, it's under promise and over deliver. They work hard, they're dedicated, and here's one thing I think differentiates Berkeley from, or I would say the UCs from a lot of other schools, which is it's tenacity, which is being able to not take no for an answer. So when you go to Berkeley, at least I can say everything's not handed to you on a silver spoon. And some people don't like that. They want to be taken care of. So they might go to another institution. But Berkeley, you got to be in there, you get to learn how to be tough. You don't get into that course, you go in and stick it out. You camp out on the professor's doorstep. You get what you need to do, right? And you get it done. So that, some may say, well, that makes Berkeley a little more, less comfortable. But I would say that's a benefit, in the sense that when you come out of that program, I don't know if these guys will agree, but when you come out of that program, you're tough. You've learned how to get what you want.
Got it. I'm sure in the last 3 days there's been a lot of conversation about artificial intelligence. You've heard my panelists talk about robotics like a million times. And I feel like if I don't dive into robotics here, it won't be a successful panel. But I think it's also important to sort of focus in certain areas. And I'm sure there's a lot of great machine learning, Gen AI apps, and all kinds of things. But let's spend some time on robotics, right? We saw in some of the recent keynotes from great entrepreneurs, humanoids on stage. You've got the robotic dogs. I was trying to get Ken to bring one of those. He said it's a little complicated to bring on stage and hang out with us. But let's talk about the intersection of robotics and artificial intelligence and machine learning. What's going on there? What's the reality? What are the applications? Do you want me to go to Max first?
Yeah.
Let's do that. Okay. Because you've got a startup doing this.
Yeah, so the unfortunate reality in industry is that there are very few actual robot deployments of these AI, sort of AI-enabled robotic systems. And that's for a few reasons. There's the infrastructure, the software infrastructure to enable this is very outdated, very archaic. So there's every company needs to build up a lot of plumbing. At Jacobi, that's part of what we do. We help companies build out. We provide our software infrastructure for these robot arm applications. And the second part is also maturity from the customer point of view. Educating the customer, getting them comfortable with these AI systems. But from the industry point of view, it's still very much early days. We see many companies, and every week I get new decks from new companies being started in this space. But in terms of, again, coming back to robots in the field, that's still pretty limited.
So you just went out of stealth. You raised $5 million with your eyes closed. I begged you to write a check, and you said no. I invited you to the panel, and then after that you said okay. But what's going on here? I mean, you know, like, is this a crazy time that just because you described it as, I've got software for robots, and I've got a nice slide deck that talks about an operating system, how do investors get so excited? And how were you able to convince them to just write you this check for the seed stage of your company?
Right. Well, you know, again, coming back to our way of thinking, you know, rigor. You know, we're differentiated from other early stage startups in the sense that when we went out to raise this round, we already had our software running on live robots in factories in the US. And so they could speak to our customers. They could look at our usage data, and they could see that this software actually works, right? And I think that was sort of a big factor, right? The technology, of course, is important, and there are many sort of technology breakthroughs behind this. Right. But it all comes down to robots in the field.
Okay. Ken, this is your second startup.
Yes.
Ambi Robotics is your first company. Let's talk about robotics and logistics.
Oh, great. Okay. So I'm very excited about this area because unlike self-driving cars, where if you make one mistake, it could be all over, in logistics, which is basically handling packages for e-commerce, which is what we do at Ambi, you can make mistakes. They actually, everybody makes mistakes. You drop a package. It's not the end of the world, and it's okay. So we don't get 100% accuracy, but we're getting up well above 90%. And the breakthrough is that we are able to now pick up packages of any shape and size out of a bin, scan them, and then put them into new bins according to zip code and address at superhuman rates. And we couldn't do that 5 years ago. Now, it turns out that that's filling a very important need because there's more and more e-commerce out there because of changing in shopping patterns, and that's just growing. So we found this niche that has been very exciting. I have to say, it's very interesting that we're two mechanical engineers up here and two electrical and computer scientists, because that's exactly the team that is the full-time team that founded Ambi. And they work very closely together. So we have amazing mechanical designers who are designing new machines, and it's everything down to the details on the suction cups and the motors and how everything's lined up that really matters. And the software is brand new, using AI. So putting all that together, and the nice thing is that we have now crossed the line to, we are sorting 1 million packages a week at 100 locations.
1 million packages a week?
A week.
And who's using this?
Oh, sorry, the postal system is using our systems, Ambi system.
So you're definitely making the U.S. more productive?
Yes. We have 50 people.
That wasn't meant to be a joke.
Okay, good. No, the postal system yes, can use some productivity improvements. The hope is that you can order something and you'll get it the same day, right? We're not there yet, but they're getting closer. So there's a lot of pressure to push that. More and more people are ordering on e-commerce. And one nice thing is we've now hit this critical mass where we have 100 machines operating round the clock, and we're collecting data from all of them. So we now have a data stream of information. Every single package we can see at our headquarters on our dashboard, and we can check whenever it fails, we can diagnose it. So we're constantly updating the software. And so it gives us an advantage because we're constantly able to do these experiments in real environments and then tune the whole system accordingly.
So let's dive into data, and I'm going to come back, Tara, in a minute here, but you just brought up data, right?
Yeah.
I think one of the biggest creations of data is coming from AI use cases.
Yeah.
With that, you need data centers. With that, and all the electric vehicles out there, you need a lot of electricity. That's stressing out the power grids. And if the demand continues the way it seems like it is right now, we're going to hit some real bottlenecks in our grid infrastructure. So I've laid out one problem for you scientifically that a lot of people are grappling with at the moment, but that's not the question I have for you. You can touch on this. The question I have is, you're in the lab with great students and talented minds. All of a sudden, AI is this new realm of possibilities for problems that we've had. How do you sort of not invest, but filter all these great ideas from your students and say, aha, that's one we should spend time on from a research perspective, right? Because it's not about whether it raises money, but it, in 3, 4, 5 years, can have a breakthrough in the fundamental infrastructure or things we need to make the world a better place in terms of AI and machine learning. Is that a complicated question?
No, I love that question, Jagdeep. It's a great question. It's a matter of, I have to say, it's one of the things that is, when you choose what research projects to work on is really an art form. And you mentioned I work as an artist, and some people in engineering especially think, well, artists is easy, it's easy to make art. But actually, no, it's very hard to make art that's truly original. And the only way to make art that's truly original is you have to read constantly and know what everybody else is doing. You have to be a scholar. And it takes years and years to know enough to make new art. The same is true for science. You have to be constantly listening and having your antenna out there to know what other people are doing, and then having these gut instincts about something that's really new. So I'm always looking out for that. In other words, we don't jump on the bandwagon of an area that people are working on. So sometimes students will say, well, I love this project, and I'll say, well, it's too crowded. Lots of people are working on that. Let's go somewhere new. And there's so many new areas. But we're constantly talking with each other, thinking about where these are, and then making certain bets. And for example, many years ago, when the World Wide Web first came out, my students and I built a robot and attached it to the internet. That was in 1995. And it got used by 100,000 people. I mean, people all over the world were using our robot. So that got me very excited about the potential of the internet and robots. So now, today, 30 years later, there's something called, or 40 years later almost, there's something called cloud robotics. And it's just starting to be accepted and adopted. And I'm so excited about it because we've been working on this quietly with the students in the background, but now Google is very interested. We have Bosch is very interested. A number of companies are coming to us. But that was a case where, and again, not all of our bets work. Okay, there's definitely some failures, and I'm happy to share this if you want. But that was one where we saw a glimmer of some idea. It took a long time, and nobody else was really paying attention to it, but we kept pushing, and now it's really starting to flower.
So you got to be patient with these things.
Yes, yes, yes.
Tara, let's switch to, are you helping any companies with their problems and solutions using artificial intelligence and robots?
Yes, I'm working with Toyota Research Institute, actually, and I'm helping them work on robot navigation in the wild. So they're currently
Did you
interested.
say in the wild?
So that means like any given environment.
I thought all Toyotas need to be on a road.
No, you're not talking about the cars. You're talking about the robots.
No, I'm talking about their
Oh,
robots.
Toyota Robotics.
Yes,
Okay.
Toyota has a
So
robotics
tell us a
team.
little bit about them. Is there a division at Toyota that has robots?
Yes,
They do
they
all
have
kinds of
a
things?
division dedicated to robotics, and they're really interested in grasping, manipulation, and robot navigation in brand new environments, which they call in the wild. And one environment they're working on right now is grocery stores. So you have a robot go into a grocery store, actually here in Mountain View, and they have the robot get 20 randomly generated items from a shopping list. So we're helping them work on that to make it more efficient and more accurate.
Very cool. You know, Tara, let me ask you this question. My godbrother is visiting us, and if he's in the audience, he's probably embarrassed at this point that I brought this up, but he was looking at a bunch of companies to work at, and he had an interview. He was telling me the story with one of the leaders in the company, and the interview was, you know, the leader asked him about how do you know about model failure, and how do you detect this stuff from inside the company, and he thought it was kind of a silly question that he would be asked, because you should kind of know what your model, when your model's going to fail from the inside. But it turned out they were made aware of this from the outside. And so he's like, well, this is kind of crazy, and I don't think I'm going to work for you because you're asking me a silly question, so to speak. I may have paraphrased that wrongly, but I think the point I want to make with this is engineering and fundamental engineering talent is very important, and we're in this race to build things today. We're focusing on the applications. We're building things that might mimic what looks like reality, but if you're ignoring the fundamental engineering that's required to create some of these things and moving too fast, you could screw the whole thing up. I hope that makes sense, but maybe you can expand on this a little bit to remind us as to what are the skills required in these companies and solving these problems on teams that make it, you know, a team to be attached to.
Yeah, I think what's really important is being able to analyze your errors or your failure modes, really looking at those and taking a deep dive, because a lot of the time people just want to show like, oh, I have these amazing results, and they kind of hide their dirty laundry, right, these failure modes. But I think it's really important to bring those to the forefront, because that makes us aware of what are still open problems in the field. When you act like everything's working amazingly, then you kind of close opportunities to yourself and others for what are open problems. And the best way to keep innovating is to focus on where your failures are.
I just got so proud of her from that answer. That is so great. I love that. Yeah, exactly. Thank you, Tara. That is perfect answer. And she just said
That's an extra couple of great points.
For sure. You know, but she said a term that we use in the lab. We talk about dirty laundry. And we actually have a requirement.
I have a lot of that.
What?
I have a lot of that.
Okay. Well, we all do. And part of it is, you know, in papers, we actually now require that every paper coming out of the lab has a section called dirty laundry. And what we mean by that is, what are the limitations?
Really?
Yeah. And we put it out there. We actually, it's part of a requirement for a conference that I ran a couple years ago, and now they're adopting it, which is everybody should be open about their dirty laundry. Like, where doesn't it work? Show us the failure modes and talk to us about those. So it's becoming, you know, not everyone does that, as Tara said, but it's so important, because if you're really going to push things, the failures have so much interesting information. So you really want to concentrate on them.
So let's expand beyond dirty laundry to, you know, Berkeley for the first time in 50 years just created College of Computing, Data Science, and Society. Now, it's incredible. It takes 50 years to create a college on a university campus. Hopefully, the speed of innovation in AI is going to be a little faster than that. But I want to focus on the last word, society. Many, you know, my daughter, the moment I bring up AI at dinner, she's like, what are you talking about? It's bad for you. So, yes, there's also dirty laundry and there's hallucinations, but ethical implications and societal implications of being in the wild, the robot going crazy, you know, car hitting somebody. How do you study those aspects and embed them into your science on a day-to-day basis? You can look, that's the artistic look.
Well, I love that you shared that about your daughter, and I think one thing that we feel our responsibility as engineers is to reassure people that we do not see, no engineer I know, or almost with a few exceptions, really worries about robots taking over or eliminating the human race. A lot of people with very well-known people are talking about that, but engineers don't think that's going to happen, or are not worried about it, because we know that these AI systems are just not that powerful. And again, this comes back to what I was saying, the progress is happening, but it's not at any stage where any of us feel like it's threatening. So that fear is overblown. I think there's some fears also about jobs, that robots are going to take over all the jobs. And this is something else I really want to push back on, because I don't think so. I think that robots and AI are going to be complementary to our human skills. And robots and AI have nowhere near the dexterity that even a baby has. And we've been working on that I've been working on it for 45 years, and we're making progress, but we're still nowhere near that level. So all those jobs that involve using your hands, gardeners, construction workers, electricians, those jobs are safe. There's no way they're going to be taken over. And I still think that's even true for truck drivers. I don't think we're going to replace truck drivers in the foreseeable future. So all this hype and the fear is science fiction. So I think it's really important to push back on those fears that are surrounding AI. And I don't think it's going to happen. I think we're going to have is that AI is going to make us better at what we do, all of our jobs. Even, let's say, graphic designers, everyone's saying they're going to be wiped out. No, I think the good graphic designers are going to learn how to use DALL-E and Stable Diffusion to make better designs. So I think they're going to complement us and make us better. That's how most technologies have played out in the past few hundred years.
Cool. Let's just have some fun and let's ask each other questions.
Well, I've got one for you.
No math questions, but yeah, let's just do that. I mean, I've asked you guys questions, and if you want to ask each other questions, let's take a couple of minutes. And
right.
The audience has been sending in some questions. What happened to my time? It went from 9 to 15. That is obviously AI manipulated right now. It should go the other way, so somebody should check your AI algorithm on that clock. Literally, I'm not kidding. But I have got some interesting questions from the audience. I'm going to ask you guys, but let's.
Well, can I ask you a question, Jagdeep?
Of course.
Because I have to say, you've been really doing a remarkable job. All of us
I love you.
At the UC system appreciate that you're doing a great job with our nest eggs, really. And I'm curious how you think, because your reputation is, there's so many people in investments who sort of follow the herd. And there's a new idea, and then everybody runs over there, and then everybody runs. You don't do that. And I'm curious, how do you think about these trends and avoiding that kind of groupthink?
Well, first of all, I wear a turban, and it's pink, so I can't find a herd to follow.
I'm going to quote you on that.
Bad joke. And what you don't know is I am his personal money manager because I manage his pension. So we have a good relationship. And right there is our secret sauce. So we manage, look, it's tough. If I showed up in Silicon Valley here or in Mountain View, the only conversation is cap table, allocation, slice of investment. We can't compete. We're not smart to be able to get access to those opportunities and beg our way into a company. But what nobody here has is a relationship with Ken Goldberg like I do. I think so. And we have the brightest talent at the University of California. So most of what we invest in is pretty commoditized, but where we have a competitive edge is our students and our faculty and our entrepreneurs. And if I can find a way to hang out with you, like on panels like this or back on campus, I can find an Ambi Robotics. I can find a Jacobi Robotics. And my team and I are sort of scouring the universe. in the UC system, because we have 10 campuses where we can look for these opportunities. But lately, we're actually even going one step earlier. We have now trained in the UC Investments Academy out of our office 2,200 students in the last 24 months. And we hope that one of those students in the next 10 years might start a company or get involved in finance, and we can get access to them because they started that journey with us. So in order to look for opportunities in a very sophisticated crowd, you have to kind of find what is your edge. And that's the only edge we have, is the University of California. Now, for most people in the room here, that is a killer edge. And we own it. So why not spend time in your backyard to look for those opportunities and always chasing a shiny object in some other part of the world? So we've done stuff with you. We've done stuff with folks at UCLA in immunotherapy and immuno-oncology. But sometimes it takes 10 years. It took me 10 years to meet a professor. And 10 years later, when he did a startup, again, we came in and invested in it. But you know what? You got to be also, I'm going to end by saying, I think I wasn't kidding about a pink turban and a Sikh. You just have to be comfortable in your own skin. And you can't be chasing something else that you have no control over. And so when you're looking for opportunities, I think it's the same thing. You got to know what you know, and if you don't know it, stay the hell away from it, because you're going to get surprised. So the most important thing when you're investing is knowledge. And that knowledge comes from hanging around with you guys. So you're my competitive edge. You may not realize it, but you really are for me and my team. And that's the most important thing. And you know, last but not least, I'm managing your pension personally. You're not going to screw around with that. You're just not.
Okay.
You're not going to give me a bad idea.
No.
You're not going to give me failed models. You're going to give me the straight bill of goods, and you're going to tell me what the model failures are. And I will make a decision with my eyes wide open with the team. But at the end of the day, there is a trust that is involved in doing that. And when you hang around within your own community where you can find those opportunities, trust is something to work on when you build upon these opportunities. So anyways, I don't know if I answered your question.
No, it's a great answer. Thank you.
I'm serious. They literally added 5 minutes to us here. Okay, let's go to some questions from the audience. What should the role of government be in managing artificial intelligence? We haven't touched on government. Not Elon Musk, not the state of Elon Musk, but the other government.
Right, the U.S. government.
Yeah.
You know, it's interesting. You may have heard
And
that.
actually, can I add something?
Sure.
Let's talk about U.S. and the Chinese government while we're at it.
Okay. Well, you know, it's interesting that this big report came out from President Biden had an executive order on artificial intelligence in November or so. Came out of the 100 pages long and had a lot of, he was basically anticipating a lot of the concerns, certainly about overseas competition, but also about how things could be used, for example, against vulnerable people. And it was interesting because we were invited from the UC, we're invited to go to Washington and meet with the authors of that report. And I remember it was very fun, lots of discussions, and then at the end they said to us, well, was there anything we missed in this report? And it was funny because I've been waiting to say this all day, but I said, you didn't mention robotics. and there was a moment, and I wasn't sure, I felt a little bit worried about saying that, but there was a beat, and then they turned to me and they said, you're right. Like they just thought of it, and they said, what did we miss? And then we ended up having a 2-hour discussion. So it was very fun to be able to have some input there. And so I think it's nice that the UC, as a public institution, is engaging with government to help government think about these policies. And I do think that it's really important. I'm a big fan of openness. And by the way, that's another thing that UC has been very big on is open source, sharing a lot of code. So in the discussions about AI, I'm definitely from the camp of open it up, let people experiment, don't try and control it, but at the same time, do have some guardrails.
Okay. Max, in the world of sort of robotics in companies,
Yep.
how does government play a role in terms of regulation for you?
So there are many sort of safety regulations, and of course we need to follow those, and I think it's important to follow those and to consider those regulations and rules when designing these systems. And in addition to government, there are also companies have their own set of restrictions and constraints that we need to consider. Beyond that, I think the most important thing is really engaging with industry. Echoing Ken, right? I think the most important thing is to have a conversation, trying to understand what are the pain points, what are the needs, where does government need to step in, and then act accordingly. But it always has to be the result of a conversation.
Got it. Tara, you've got to do me a favor. I've got to introduce my daughter to you. She's 16, and you've got to at least let her know that Dad is serious about AI. But what does the future look like for you 5 years from now? What excites you about the opportunities? By the way, that is one of the questions. What are the opportunities in artificial intelligence that you want to be attached to that will make you a billionaire?
I think right now everything is very interdisciplinary within AI. It's not like there's the computer vision people, the robotics people, the language people. I think all of us are coming together and people are realizing that we all need each other to make very high functioning autonomous agents and robots in various settings. So I think that's really exciting for the future, learning about all these fields and figuring out where are the great intersections for them to work together.
So how do you...
Just because we were talking a little bit about senior citizens and the aging population, which is also something that...
Yes.
Oh yeah, let's talk about that.
Yeah.
Oh yeah, in terms of applications, if that's something you're interested in, I would say senior citizens definitely, like making robots that can assist them in the household, because I think senior citizens are a very vulnerable population and it's also very expensive to take care of them. But getting a robot is basically a one-time purchase. It's not really like how you have to pay a nurse every month or something like that. So it's cost effective and it removes a lot of the concerns you have with how a nurse treats the elderly and all of these other logistical things. You can just have a robot like declutter their house for them, clean things up, help them put on their coat if they have arthritis or some sort of bone problem and things like that. I think the elderly is a really interesting market, and also cobots, robots that work with humans in factories and places like that. So for example, like Ken was saying earlier, robots are not very dexterous like humans are, where we can like move a pen in your hand the way he was showing. But a robot can carry around heavy things for you and not get injured the way a human would. So the robot can do that for the human, and the human can do the more dexterous tasks. So they can work together and complement each other nicely.
So is it realistic, though, to expect a robot to help an elderly person put on their clothes? And if they can't even be dexterous enough to, or, have the mobility that, like this, is that a 1-year reality, 2-year reality, or a 25-year reality? I mean, it sounds cool, and I'm certainly not funding a startup at this point to do that, because I'm not convinced. But convince me that this is near-term and fundable.
It depends on the extent to which the elderly person lacks mobility, right? So if the robot can pick up the coat for you and hold the sleeve wide open and the elderly person just has to move in, that would be possible.
She's being super modest because she's working on a new technology and a paper that she's writing as we speak that is going to allow her to model garments. And so that's why she brought up that example.
Okay.
And it's a brand new thing. So, it's a great point. So it's not ready for prime time yet, but and it won't dress a person who's completely, passive on the floor. But it will be able to assist, and that's exactly what one of her research projects is. So it's something that's real. And probably, how long do you think it would be before that's something that could be on the market?
Probably a few years.
3 to 5 years?
Yeah.
Okay.
It's going to have a hard time dressing Ken and I. Too many flowers to put on our body.
Tying a turban is probably tricky.
Yeah, well, you know, if you could have a ready-made turban and just put it on my head,
okay.
That would work well too. It won't get the compression right, but we can figure that out. That's interesting. I can see that happening sooner than later. Okay. So a number of people have asked a question, which is, how can they partner with researchers at universities where a lot of the deep science and thinking is taking place in order to then create what could become, you know, a breakthrough company? How does that work?
Well, that's another nice question. I have to say, there's a number of things we do for the public because, again, we're a public university. So we offer a number of lectures that we make open to the public. And so people can follow those. And the Bair, it's Bair, bair.berkeley.edu. And if you go there, there's a list we'll list those events when they're available, and you can watch them on Zoom, is one way. The other is interesting because we publish all of our papers very openly. So we're very quick to put out our results. We want to share them with the world. So there's something called Archive, which is relatively new. It's a public repository for research papers. I think many of you know about it, but it's run by Cornell. It's ARXIVE, where the X is like the Greek letter chi. Archive is a wonderful resource, and if you go to that site and search for any topic you're interested in, you'll be able to pull up the most recent papers. And that's what we do to find out what's going on. So the public can do that. Anyone in this room, you can do it tonight. There's no payment whatsoever. It's free and open to the world.
So Archive and Bair.com.
Bair.berkeley.edu.
Bair.berkeley.edu.
Yeah.
You know, one of the questions you maybe forgot to answer was the China question. Before COVID, it seemed like China was overtaking us in America on artificial intelligence research. Here we are, and it seems like the geopolitical landscape has shifted. But are we going to live in two worlds of two kinds of robots, you know, two different standards, two different technology platforms, two different open AIs? I mean, what does the landscape look like globally between China and the United States in AI? How about
Max.
Let's go to Max, because I'm sure with robotics you're dealing a lot with.
Yeah.
I mean, some of the best robotics companies robot companies are out of China at a very cheap price.
Yeah. So we see a lot of robotics companies coming out of China, and China has been very good at adopting robots in industry, in manufacturing, in logistics at a very large scale. And part of that is because of government subsidies. They certainly have a lot of resources, but we haven't found that, in a way, a lot of the innovations still come from this side of the Pacific. Right? Silicon Valley has been discounted so many times. People have been saying, this is Silicon Valley's dead, no more innovations from this place. But every couple of years, there's a new innovation coming from here, right? And I think that's the key for the US, right? That this is a place where people from all across the world, they travel here, they work together, and they make breakthroughs. And that's something that we haven't recognized with the Chinese robotics companies. That's something that we haven't seen there. For them, we've seen more commoditizing existing innovations.
Are you working with Chinese companies?
We are not actively working with them, no.
No.
But I'll add to that, which is I have a huge respect for China and the Chinese researchers. They're amazing. And we are very lucky in this country that we have, to the degree that we have opened doors for immigrants from India, from China, from Pakistan. We have in Europe, we have Eastern Europe in particular, so many brilliant researchers coming in. And I think it's because we've created an environment that tends to be attractive, right? But just what we were saying about having good engineers, engineers want to be with other good engineers.
Right.
It's a natural affinity. So China, it's interesting, we don't feel this barrier in the same way. We share our papers with China. We read their papers. A lot of our students come from mainland China. We use the robot dog that was developed in China and is a beautiful, you know, the very expensive dog from Boston Dynamics costs about $75,000, but you can buy that for $2,500.
$100, yeah, almost less than $3,000.
Less than $3,000, and it's made from China. So we buy those and we do research with them. So, you know, I think there's actually a much more synergy. I don't think it's going to be two worlds. I mean, you can't stop the kind of exchange that's happening in research and academia. So I'm very positive about that. I actually, you know, a lot of these things, I understand there's these frictions in the world, but I'm an optimist. I do think that ultimately people will figure it out and learn how to get along.
Awesome. We're at 1 minute and 15 seconds. I'm sure we could go on, but I'm going to try and wrap it up earlier. Very quickly, 10 seconds. One piece of advice for a young UC student in the room, Tara, as it relates to AI.
Focus on fundamentals and be very well read.
Ken.
Don't take no for an answer.
Max.
Join a research lab.
And I will say be curious. Now, none of us are the name brand speakers you've had in the last 3 days. But what we are is hopefully realists, and we're very excited about what a new future could look like. And I do think, candidly, the future does not belong to name brands. It belongs to students like Tara, professors like Ken, entrepreneurs like Max, and a lot of hungry other people that are willing to partner with them to change the world. 5 seconds left. Thank you all very much.
That was great.